Okay, hello everybody, good evening. Welcome to the panel discussion that was organized here by the Fyziklání, by the event that you are participating in. We will be discussing what physics can, or what kind of careers or futures can physics bring to you, young students. I suppose you're mostly, or all of you, high school students. We have a selection of young but distinguished scientists here that were, well, okay, some young and some distinguished. And some both, of course. Yes. The overlaps are inevitable here. And we will try to give you some, or we will try to discuss this issue of what physics as a career is like. What is it to be a physicist? What is it to be a scientist today, or maybe even what it was some time ago? How the studies of physics go. At least we have an experience from the local faculty. We found that all of us went through the same school. Nevertheless, maybe some of these things that you will hear here will inspire you or will give you some insight into what physics study can look like at other universities too. So let me introduce my guests. I will basically just tell you what are their names and what institutions are they working on at these days. And then I will ask each of them to give a very little overview of their current work. I think it's very important to see what their actual subject is. Okay, so we start with the lady. Dr. Anna Fučíková is from the Faculty of Mathematics and Physics of the Charles University. Welcome. Thank you. Then, at least now I can say that we start from the age down. Dr. Antonín Fejfar from the Institute of Physics of the Academy of Sciences. And I'm now no more sure, I just make a random selection. So we will welcome here Dr. Aleš Podolník from the Institute of Plasma Physics of the Academy of Sciences of the Czech Republic. And Dr. Martin Kozák from the Faculty of Mathematics and Physics.
Good evening.
Okay, my name is Tomáš Mančal. I'm from the Faculty of Mathematics and Physics too. All right, so let us start then with the very short introduction of our subjects. Everybody, if you can, say a few words about what you do, what is your main topic, what are your scientific interests. Martin, maybe you can start from you.
So I'm coming from the Department of Chemical Physics and Optics, but my part is mainly the optics. So the group historically does ultrafast laser spectroscopy of semiconductors and semiconductor nanostructures. And nowadays we are working on extension of the time and spatial resolution of the methods which are used in this field towards atomic spatial resolution and attosecond time resolution. So we are building a new lab for ultrafast time-resolved electron microscopy. And so the goal is basically to image the fastest dynamics which occurs on nanoscale with very fine spatial resolution. So that would be it from me.
Okay, thank you.
So it works good. So I work in the same department as Martin, but my concentration is a bit more interdisciplinary. So it's between biology, chemistry, and physics. Generally, interaction of nanoparticles, nano stuff with biological stuff. So that will involve mainly atomic force microscopy and other techniques which work at nanoscale. So it varies, like whatever sample we have, we study it from the cells till nanoparticles, till some membranes for medical application in the real operations of patients.
Thank you. Maybe I'll just say that may be quite important because I forgot to tell you that Anna is not only affiliated with the Faculty of Mathematics and Physics, but also with the Institute of Physics of the Academy of Sciences and with the University of Chemical Technology. Yeah?
The problem is when you work in the interdisciplinary field, not every student is capable of that. So we need to connect chemists, physicists, and biologists. So that's why it's better to help and select the best students from all the faculties and give them some really nice environment so they can enjoy to work in between the disciplines. So that's the main reason why I'm on the 3 institutions.
Thank you. Okay.
Good evening.
Aleš?
I'm not from the faculty now. I work at the Academy of Sciences of the Czech Republic, and I work at the Institute of Plasma Physics. This is located quite nearby. I think some of you are going to visit it. And we work on the nuclear fusion, and we are currently building a new device, new tokamak, that is going to be first in the world, recently built. And my part is to aid the development of diagnostics of the plasma physics, because I focus mostly on the theory of plasma-wall interaction and the plasma edge. And well, I do it through computational physics.
Okay.
I'm the last one.
Yes.
I allowed myself to have a product placement with me. For those of you who are Czechs and can read it, this is my affiliation, Fyzikální ústav, Fakt zábavný ústav. In English it would be Truly Entertaining Institute, belonging again to the Academy of Sciences. You have seen it, so I can sit down now. In some sense, we are in the same field, because my field is photovoltaics. And photovoltaics is the energy conversion of the sunlight, and sunlight is the product of the fusion. Only we already have the reactor while you are working on it so far, and we are working on a practical way how to use that energy. That's photovoltaics. In my understanding is the way how to save the world, which I think is worth remembering. Yes.
Thank you. Okay, so yes, if you can of course clap, this was excellent. All right, a little break here just to figure out if everybody hears us well. We have a first round here, so if somebody has a problem hearing or understanding, we'll do our best to improve that. Is everything okay? All right. Yep. Okay. Thank you. Okay, so thank you all on the panel. Well, maybe I should also say something. I'll try to be a little bit in the background, but I'm also a physicist. I'm not just a moderator. And I realize I'm the only theoretician here. So I'm a theoretical physicist. I work in open quantum systems. My excuse for doing that is doing photosynthesis, which is relatively near to photovoltaics. And I, of course, also, as most of you here, teach at the Faculty of Mathematics or Physics, or some of us teach. That will be also an important part of our discussion, I suppose, that teaching or studying experience. Before we start with the actual topics of this panel, I want to express how happy I am to be here, because I realized today that I am 30 years out of high school. And when I finished my high school, it was impossible to expect that me and my buddies from the high school would go to a discussion like this, and they would be expected to listen to a bunch of people speaking English, and we would be expected to understand. The sheer fact alone that we have here some Czech students that could follow all this, and that all of you can follow things in this scientific lingua franca in English, is something really worth realizing and remembering, because this doesn't come just by itself. It expects certain type of environment and certain type of, I mean, I don't want to say bold words, but certain type of world order. And we all probably want that this, at least this aspect of the present world order is kept and allows us to do what we do, I hope, best, to do science in the future. So let's not forget about this when we'll start to discuss topics that are relatively technical or topics that might sound like personal. We all work in a big environment. You know, our physics or our science is an open system, something that I study. And an open system very much reacts to its environment. So we have to be, you know, aware of the fact that we don't work in vacuum. All right. So our topic is, at least some part of it, is about scientific careers. What is it like to be a scientist? So maybe our next topic of discussion. We will start with monologues, but hopefully there will be a discussion. Is the simple question: what led you to scientific career? Maybe we can start now from this side. And so, can you tell us a few words about what led you to science?
I had no choice.
Excellent.
You remember that this was a long time ago when you were deciding, even longer for me. So we were living at the time of the communist Czechoslovakia, and I had hard time to be accepted to the high school already. Actually, I was refused 3 times, and I already was enrolled to become a lathe operator in one machining factory. Then I was lucky in some sense, and I realized that out of all possible schools, physics is an open possibility because I was able to do the physics competitions, perhaps the same kind of like you are doing now, except in that time it was Physics Olympiad, or Fyzikální olympiáda, wonderful thing. And I was able to excel in that. So I did not win it in Czechoslovakia. I was on the number 5 to 9 divided place, which meant that the faculty will accept me without the entrance examinations. And I had a feeling that nowhere else is the same chance. But it was also a good choice. So that led me to it.
So would you think that if the conditions were different, you would end up somewhere else?
I almost was sure that I would like to be a medical doctor. But there was no chance. In some sense, I think it's better choice to go to physics. It's the same, like long time ago we had a discussion. If it is better to be a theoretician or an experimentalist to get a Nobel Prize.
Theoretician, that's clear.
The question is not so easy to decide. You get the Nobel Prize if you are a young theoretician, and you get a Nobel Prize if you are a little bit older experimenter. So the optimal choice is to start as a theoretician and then do the experimental physics later.
Okay, thank you. Excellent. Yeah, Aleš.
Thank you. What did lead me to the scientific career? I was thinking about the answer before I came here, and there are 2 possible answers that I came about. First one is that I was basically a science fiction avid reader, and I wanted to do something like that. And well, the straight path to, let's say, make an impact towards the science and science fiction is to study physics and apply it somewhere in the related field. But the most probable answer is that there was a random decision or a random event, because when I was in the 3rd grade, I was given the opportunity to go to the physics or mathematics Olympiad, and it started like an avalanche of life choices that led me eventually to the faculty. And one of the choices was actually attending the FICOS competition that is behind this whole event, and then I became one of the organizers. I also took part in Fyziklani since the first year, and among the students, I found several people that were actually doing nuclear fusion, and it led me to the decision to go to the academy and follow this topic.
Was the science fiction more important than popular science in your decision?
Yes, of course. There was, I think, there was no popular science events when I was, well, in the age of 10 or 12 that I could attend or that I knew about, except some astrophysical events in the planetarium or observatories.
Okay, thank you. So Anna, what about your motivation for scientific?
For me, it was a bit complicated. I started to decide already on grad school what I want to do with my life, because everybody was thinking that I'm not the clever one. I'm dyslexic, dysgraphic, and dysorthographic. So I just started to go different Olympics, like history, then nature sciences, and then one student was having a really stupid idea to send me to language Olympics. I was like, okay, not good idea. Indeed, it wasn't a good idea. But then I was thinking, okay, history, biology, and this kind of stuff, you just memorize stuff, and then you can be the best, and it's boring, in my opinion, I'm afraid. I didn't know molecular biology in that time as an excuse. And then I discovered, okay, if you do physics, then in physics there will be always another doors which you can open and learn something new which you didn't know before. So it's like an infinite pool which you can dive in and just enjoy discovery each day. So that was like the main thing for me to deciding that, yeah, I would like to do physics. And then there was another point, because me as a female, I was thinking how it would be to study the physics. And then I would look on Star Trek, and there was the Captain Janeway. And I was like, if a female can rule a ship in Star Trek, I can become a physicist as well. So it's part sci-fi and just the enjoyment of discoveries each day, which led me to physics.
So for me, I'm actually coming from a relatively small village here in Czech, like 30 kilometers here from Prague, and I was just curious how the things work, and it's a very nice thing on physics and math, or these in general these precise sciences, that basically you can predict what happens when you know the state of some system before, and you have some theories which you can verify experimentally, and by this you can really explore a lot of things in our world and understand them. And this is, I think, like a nice motivation. So when the subject of study and then your work becomes your hobby, that's the best combination which can be like motivating you to work in this field. So this was the motivation for me.
Thank you. Maybe a question to all of you, and you can pick it up or not, any of you. There are some, nowadays it seems like for everything, in order to promote it, you need important people that are visible. I would say for me, this was Jiří Grigar, something like the Czech Carl Sagan. I suppose that you know this name in astronomy. This is basically an exact copy of that career, but in local environment. Do you have any inspirations like this? Individual scientists. For women, very often Marie Curie is, for instance.
No, Richard Feynman.
Richard Feynman, okay.
Because he said on the Navonovo there is plenty of space for discoveries. So.
Yeah, all right. Any other inspiration that you know about or forgot already and now you remember?
Yeah. I should say that because there was a person like this for my decisions, and that was Čestmír Jech. The name you would probably not know. But it's a story, and if I tell you this story, then I will be satisfied and I will not have to speak anymore. But I should say the story. The story began when I was 16, and I read this journal, the Vesmír, which is something like a Scientific American, a local one, and there was an article about the thermonuclear fusion by Čestmír Jech. And I read that article and I understood that this is a wonderful challenge. And I wrote the editors of the journal to send me an address of Čestmír Jech, and I wrote him a letter, and I still have the letter, I should say. I found it recently. The letter was a letter which a 16-year-old guy would write. So it started first with a criticism of his article. So then the second part of my letter was that I have just decided to solve that problem, and I asked him for advice how to do that. And the funny part, and the one which I still appreciate, is that I got a reply after about 3 weeks. That was the time when you got letters, and his letter was typewritten with the typos marked with a red pencil, and the letter was wonderful because in the first half of his letter, he just ignored my criticism. But he gave me a very important advice, and that advice I want to tell you, because it's not mine and not even always his. He told me that it's not so important on which subject you work, because all subjects are wonderful. It's up to you to make it wonderful. But the most important message is you have to find good people to work with. This is absolutely the most important thing, because your life can be beautiful or it can be hell, and it depends on people you work with. So that was his advice. Then there was a second one, and that was you should not concentrate to physics in the beginning. You should learn languages, and you should find what you really like. And if it is physics, that's good, you will be happy. That's it. That's the letter. And you don't have to listen to anybody else, anything else, but I should tell you the sequel to that. There is a continuation. So I was already a PhD student here at this faculty, even it was in the lecture hall in the next building. And Čestmír Jech came to give a seminar. And after the seminar, I was already a PhD student, so it must have been something like 15 years later. And after his seminar, I went to him and I told him, hello, Professor Jech, this is me. I wrote you that letter. And he said, wonderful. I was waiting for you. And he said, you should know that when I was young, meaning Čestmír Jech, when I was young, I wrote a letter to academician Běhounek, František Běhounek, who was, you probably don't know that name, because this is already an old story. He was part of the Nobel expedition to the North Pole. With they even crashed there. They had the how is it called, the Zeppelin or airship. They had an airship and they crashed at the North Pole. They were saved about 2 months later. He was absolutely amazing adventurer. And Mr. Jech wrote a letter to Běhounek, and he got a reply. So he said that when he got my letter, he knew that he's obliged to write back. And I'm still waiting for the letter. I know I'm obliged to write back, but I am also telling the story. And the story is a continuation, and you can have a very nice life in science, and physics is especially good way how to go there.
Thank you. Thank you. I think we will get to some of these things in detail later. For instance, how important it is to choose the right people to work with. Let me now open this part which considers this studying of physics. unfortunately, all of us went through the same school. I said, well, we were supposed to have one more panelist who is apologizing because of her health, who went through a different school here in Prague, but our experience is therefore a little bit singular. Nevertheless, I believe that university life is very similar everywhere. So I will give you basically two questions in one, and maybe we can start again from Martin down back to me, which consider the studies at the university. So what was the best and the most difficult, or the worst and the most, the best and the worst part of your studies, the most difficult and so on? And did you actually go to university with a decision about what kind of physics you will study?
So maybe I will start with the second part, not at all. So basically, even I was not sure if I will study physics or some other, for example, math or informatics here at Matfis. But before I went to the university, I made the selection based on sort of the best, or the physics became to me as a best option to be able really to verify things practically, like experimentally. You can confirm some theory which serves you to predict some phenomenon. But then when I came to the faculty, I found that there are, of course, like many difficult things. Before you learn physics, actually you cannot decouple it from math, so you will have to study a lot of math. And so you become a little bit of a mathematician during the first 2 or 3 years. And here at the Faculty of Mathematics and Physics in Prague, I think the best thing is that we were taught in sort of a little bit abstract way. So the study program learned us how to solve different types of problems. Let's say not only in the traditional ways. And this is what I liked very much. But on the other hand, sometimes I found it also very hard, because some of these subjects are very complicated when you go deep to the physics, whatever, quantum electrodynamics or relativity theory. There are, of course, very complicated mathematical theories which you need to absorb to understand the phenomena. But as I say, so this abstract thinking, I think, is one of the most important, let's say, properties of a physicist, because then you are really able to come up with something new, or to synthesize things which can go relatively deep to some specific field. And then this becomes also like beneficial to you in the future. So yeah, this is it from me, I would say.
So my physical education at your stage was practically non-existent, like really bad. So then I decided to go to Matfis, and for example, the worst thing was linear algebra for me, because I never integrate before. So it was like Chinese with Japanese subtitles, when you look on that. But in the worst, the best came out as well, because if you do not give up, then the teachers in this school do not give up on you. So they helped me to survive. First year, I almost didn't pass. But in the 5th year, I got the best marks, and it was all because of the environment which was on the university. So if you do not give up, the teachers do not give up on you. So just be resistant and just survive. And I wanted to be a theoretical physicist, but I said no after first year, because there was plenty of linear algebra in there. And since I sometimes forgot to put plus and minus on different sides, then I was thinking, okay, the career is lost for me, let's better be an experimentalist.
For me, the decision was not really clear to if I actually choose physics, because after most of the years in high school, I was inclining more to computers, but eventually through the example of friends and the teachers in high school, I choose to go here. And the first thing that I was subjected to was to find my own way to actually learn anything, because the life of the talented student at high school is quite simple, and as you go to the university, you will struggle to find actually some means how to take the subject and learn it yourself, since you are basically on your own. On the other hand, you have the teachers and your friends here, but coming through that, you'll, hopefully as I did, look back and see that there was a clear path you took, even that you didn't know that it was a clear path then. You will identify some blind alleys that you didn't take, and you didn't take them because, well, you actually had something in mind, and well, it came to you later. For example, I didn't know what I would study as a bachelor's topic or master's until I went here. But if I look back, I now see that there was no other option.
Thank you. So, the best and worst experience from studies. This is from the very past. You know? Do you still remember?
Aleš already said that. Yes, for the bright student, and I expect that this is your case. At high school, you have a nice life because that's no problem. Then the first year at the university, at least at our faculty, was a shock. And I believe that's a universal feeling. I think we all went through that, and you are headed for that. It becomes quite intense, and Anna already said, don't give up. Because if you do not, then you will find out that it's not so important to be the most intelligent person in the room. The most important thing is not to give up. There is space for everybody in science, and you have a different set of talents, but you must not give up. No.
Thank you. I can basically only confirm that. My own experience was also that of shock. Actually, looking back, it's kind of a pleasant time with lots of adrenaline, lots of stomach problems before the exams. But it's definitely worth it. I don't know how you feel about that, but for me, the first and second year at the university was the time when I was basically most intensely involved in doing things that are completely new. It never repeats, even later. I mean, as you start learning more, your ability to grasp new things becomes faster and faster. But still, there are simply no more that many new things that you can learn after the first 2 years. Those things are big that you do that, and you go really deep. But the sheer amount of things that you have to master in the first 2 years, being math, being physics, is absolutely amazing. So I kind of hope that this is the case everywhere. Maybe depending on the school systems in different countries, these intense years come in different times. But here it's definitely the first 2 years of this faculty. Okay, so we already touched on the topic of choosing the field. I mean, each of you, of course, have chosen a field. I don't know if some of you actually have switched, for instance, between masters or bachelor's, masters, and then masters and your PhD. you can also tell us that story. But what do you think are the most important aspects of choosing a field? We've already heard, and my experience confirms that again, that choice is very much dependent on people that you work with. I always wanted to study astronomy or astrophysics, but never met the right people from astrophysics. I met the right people from quantum chemistry, basically, first. So I started to be involved with quantum mechanics. How was your experience, and what are, okay, besides the supervisor, let's say, what are the other good things to look for when you want to choose a field to enter? Is, for instance, that might be quite important, should you as a student take into account the current trends, like the fact that nowadays everybody's crazy about nanotechnology? Should you actually take that into account when you decide about your future subject? Maybe we can, I don't know. Yeah, we can pick up on this.
I mean, this like focusing only on the hot topics, of course, is nowadays very kind of modern and supported by sometimes also the how the funding in science is done. But like there are many examples of relatively like out of these hot topics research, which much later becomes very important. So there are like results of fundamental research which were just waiting many years somewhere in the drawer, and then were like found again much later. And I would say that like choosing the topic initially as a student is not so super important, because anyways, once you will continue in your studies and you will finish the bachelor, the master, the work on your PhD is the one where you really start to be independent or quasi-independent scientist. And even then, one can, within some particular field, switch relatively easily. So, for example, in my case, I started, as I said, with femtosecond lasers and ultrafast optics. And then after the PhD, I came to a group in Germany which worked with electrons. And only after the PhD, I started to learn something completely new. So I would say, in my opinion, like the topic which you choose in the beginning should just give you the direction, and then you will learn a lot of things which can then support your selection much in like a farther stage of your career, I would say.
Like, in my opinion, you have now two options. Either you do what you love and you don't care about the money and so on, and you will enjoy it, or you do a job which gives you enough money and time that you do what you love, that you can do it. I suggest you that you go for the first option. And I think it's like a snowball, which you need to start to throw in good direction. Like when you choose a topic, you have some preferences. So each next step is good to ask, does it lead me to my goal? If the answer is yes, even though it's a small step, it's sideways, but it's still in the front, just accept it. It will be a new experience. And eventually, when the snowball of experiences and so on will be big enough, then it will start to roll by its own. And these steps are even people, subjects. So sooner you start to throw the ball in the right direction, the bigger and the faster it will go, and it will allow you to go further. So this is probably from me.
I'd like to add that you should not look around and see what the other people are doing, because when I started to go to the university, I was not really decided whether I want to go for astronomy or for some solid state matter, and eventually I chose plasma physics, and I chose it on the second year. And I was looking around and I saw other people that were going to their for their topics that they have dreamed about since kindergarten, and I didn't see that in myself. And now I see that it's, well, not even a little bit important. It's just up to you when you find your, well, heart in which subject. For example, I started with plasma physics, and I didn't do nuclear fusion from the beginning. I did a cold plasma, mostly, almost plasma chemistry, because we are studying the reactions between individual atoms in, let's say, astrophysical conditions. But then I switched to nuclear fusion, and I'm grateful for the experience that I got before, because well, there was an experimental subject, so I got in touch with the equipment. I got some experimental measurements myself. Although I'm not doing it now, I got some orientation in that field, and I will eventually might use it in the future. Although I didn't know that I will use it.
Yep.
Tomáš, we make an assumption here when answering your question that the direction to go is physics.
Mm-hmm.
And
we
should actually verify that assumption and ask the audience if it is true or not. Like, maybe, can we ask?
Yes,
may I ask, how many of you, would you raise your hand who wants to go to physics? Ah, then that's mostly right. Then let's do a different question. Yep. Let's ask the question, who does not want to go to physics as a major?
We should ask them about humanities as well.
Yeah.
Now it's getting interesting, because these people are going against the crowd, yes?
Yeah. Salmons.
There was a question about humanities.
Yeah, maybe. Are some of you actually considering humanities? No. Or at least chemistry or biology?
Humanities and chemistry, yeah. Okay, great. I mean, I think that we don't want to necessarily promote physics as the only options of doing great science. I think science is very broad. And I would say nowadays, I think it's very important to say that although there is certain gap, maybe methodological, maybe even kind of personal gap between natural sciences and the humanities and so on, I think it's still like a lot of what we've just said here applies to humanities too. I mean, there are very interesting things to study there too, and I would say maybe this approach that Anna highlighted, love for something, is actually maybe the most important aspect in any kind of human knowledge. Is that right? Would you subscribe that? All right. Okay. So I think we'll continue with physics, but remember that many of these things that we say can be translated to physics. All right. Yeah, of course. It's a tautology, to chemistry, to biology, and even farther than that, to philosophy, for instance, I would say. Okay, good. We went through the topic of choosing the field, but we have to acknowledge also that in natural sciences and in physics, it's not the situation of everybody, not the situation of everybody who wants to enter the field is the same. And that's why I have a specific question to Anna about the role, situation, and future of women in science in general. What do you think? What can you say to the young women here?
You can do this.
Excellent.
Like whatever you decide, you can do it, because nowadays it's easier than it was some time ago. Yeah, when I started in department, in our group, I was first female after 20, 40 years. So, and when I finished, there were like 20, 10, like say 25%, 30% of female students. So I don't see a problem that you choose whatever career you want. Yeah, like you will be exot anywhere, true, still, but there are other exots waiting on you. So,
okay, thank you for your thoughts. I think we should maybe talking about assumptions. We have gone through some parts of scientific careers, but I realized very well that when I was entering, and it actually been already mentioned here, when I entered the university, I had absolutely no idea of what stages a scientific career has. I mean, unfortunately or fortunately, depending on how you view it, science is institutionalized these days. So you have to climb up the ranks if you want to do it seriously. And the first thing you probably realize that you enter bachelor or master programs at the universities, and that's about it. Most of the people, I had certainly no idea that there is also something between those basic studies and the actual scientific work. There is a PhD program, that there is a the time of doctoral studies where you basically become something more than a student. You slowly become a real scientist, and in ideal case, you finish under somebody's supervision, but you finish and you are better than your supervisor. I think that's the typical expectation. You have just 4 years to become better than your supervisor in the field that you've chosen or that you spent your time studying. So maybe we should make a little round where you tell us about the experience of your PhD studies. That's often the time when people go to study abroad. So can you tell us something about your time abroad, or about, let's say, this type of experience, even if it would be the other stage that comes after PhD, the so-called postdoc stage, where you are already a young scientist, sort of freelance, free, available to everybody, working for hire for a limited time. So maybe we can do again a round, and you could tell us something about these two stages of the scientific career.
So actually, during the PhD, the possibilities to travel are nowadays very open, I would say. So it's a very good idea to use them. And so in my case, I spent during the PhD some time in Norway, actually. So the motivation at the time was just to help my former colleague with some experiments, but even not only the scientific part of these let's say fellowships in foreign countries will give you something. It is also learning how the life goes in some like foreign country. You can try yourself how you can survive in such environment, and I think it helps really to find new friends, find new collaborators, and that the situation is definitely much better than it was like before revolution, or so nowadays really there are usually funds to supporting these travel programs. And when you want to continue in scientific career, it is actually expected that after your PhD you spend some time in some foreign institute just to transfer the knowledge wherever you go afterwards. And I think this is in general a very good idea, because this is exactly preventing us to kind of be jammed at one particular problem and spend with it our whole life. And these fellowships definitely help to broaden the view of the topic which you are like focused on. So I can definitely recommend this, and if you will have possibility to study some part of your even masters abroad, I would definitely go for it.
So the fact that you need to overgrow your boss or like PhD boss, then you need to do it in some way. And I was really lucky that I was having really good, nice boss. So he said like, okay, your English is not perfect. So you first thing after you are accepted for PhD, you go for a month for a school so your English is better. So he just taught me to swim. And then in like second year and third year, I literally spent my life in a luggage. So because I was just traveling between labs around the globe. And that was really enriching because 1 week you have been in France, second week you have been in Spain, in different labs, in different environments. And it was like, you need to get to know the people, you need to get to the lab, you need to get something in a minute or a day so you can work the 6 days which you are having left on your project. That enables you to go like quick in any jobs you select. So really select a boss in any area which is having this like open leash for you. So he doesn't have a problem to let you go and just grow in the direction which you want. And then for the postdoc, like in here I was a physicist, partial biologist, and in Sweden when I was there for 2 years, they make me a chemist. Yeah, so you can select any career you want. Only thing which you need to know, like have in the future job is that the one word matches. Yeah, what I mean with that. For example, in here I was working on spectroscopy. In Sweden, they need somebody who builds up or creates nanoparticles which are good for this aim in spectroscopy. So I know what's the goal, I needed to find the path. But since I was having this training, you go for the lab, you need to start to work within a week, then it wasn't a problem to switch like this even between the fields. So I suggest you to find a boss which allows you travel, experience, and grow.
Okay, my PhD started when I was still working part-time as a computer programmer, and it was kind of well, let's say drawback for me, since I did not had enough time to focus on the PhD as I would like to. Eventually, I dropped the job, and it was partly good, partly bad, but the most, what I gained from that was the experience from a different kind of work, because scientific work is, the work of a computer programmer is very, very strict. You have a task that you are expected to deliver, and you are paid for delivering it. On the contrary, when you are a scientist, you have to find your own way, your own solutions. And one of the solutions is to collaborate with, not even your colleagues in the laboratory, but basically with the whole world. Because as you are getting the knowledge, you are not getting it only from the people, but from the experience and from literature. And I finally graduated, and then the pandemic came. So actually, for me, it was not very open world for traveling. I made it up when taking part of the in the European research community from of the nuclear fusion. As I have a let's say a very small topic in the huge amount of knowledge that is necessary to let's say finalize this huge goal, which is to provide a clean energy and so on. But our personal contributions are, let's say, spread around the whole world. Basically, our field is very internationalized, and as I mentioned, the pandemic. For me, it was much more of the time when I started the collaboration the most. On the contrary, because when I was sitting on my place in the laboratory or at work, I had everything that I needed at one place. But afterwards, everyone started to communicate via internet. It was the means of collaborating with even with the people that are sitting normal next to. So basically the borders disappeared, and I think that we can see it now that, for example, you are here, and the internationalization of such competitions was also boosted with the realization of, let's say, work from home and anything from around the internet. And you are starting to experience it, the international scientific community on your own. Because, well, even if you are still a high school student, you have the opportunity to come here just to do what you love.
I am a different generation, so my experience is not directly relevant. But it shows a different aspect which may be worth mentioning. So to say, I started my PhD studies when there was still communism, and in my third year of the studies we started to make the Velvet Revolution here, the student strike, and I finished the PhD only after that, with the interruption of the student strikes and so on. So after that I went for my first stay abroad, which was postdoc, and I went to Japan. I came back and I found that my previous students, because I was already teaching, they are doing all kinds of interesting things. Because the change of the state of what was going on here required people who were able to do unusual things. For example, the banks had nobody who could program and think about finances at the same time. So they hired people from the physics faculty because the physicists were good at that. Basically, the task of the PhD student is, like Anna, you came to Sweden and they asked you to do the nanoparticles, right? I can imagine that was Jan Lindros who was telling you, here you have the lab, we are working on nanoparticles, do something about it. And please make it so that it is interesting. That's it. You will get no more guidance. It will be, maybe you can confirm or say how it was precisely, but this is a very typical situation. The PhD in physics is, here you have the lab, do something interesting. And the skills which you acquire is that you do something which was not done before. So those were people good for banks or something else. So if you want to develop skills like that, this is a perfect direction.
I have a lot of friends and from my schoolmates in banks and different branches, whatever. Yeah.
Actually, I still remember that when I was finishing my I think it was master's in theoretical physics, it was still expected that most of us who finish will leave science and and find jobs in banks or something like that, in programming. Actually, there is something that I can give you kind of as a task, to solve. It's very simple, but you can imagine that with these universities and physics or any other science community has to be funded in some way, and those money are relatively constant. Yeah? Sometimes they actually even go down. Yeah? So if we have this type of situation with constant money, that means basically constant number of people in science. How many replacement people, or let's say how many students of a single professor on average can become professors too? Anybody has a simple answer to this? Well, I would say it's clear it's exactly one. Yeah? That's actually a big problem, and that's the reason why so many people actually finishes studies of science and then goes through PhD, goes to postdocs, and then they end up doing something else. Of course, they can also do some other type of science because not all scientists are professors, so it's not that bad as it sounds. But there is this ever repeating and forever going issue of how to find a place in science, in the academic science or outside the academic science. So maybe let's now try to talk about that. Like how, let's say, what is your advice if you really want to stick to it and end up at the university, let's say, or scientific institute with the chance to become a permanent scientist? Because you have to realize that after the PhD and postdoc, you are still out in the open. You have all the skills, but somebody has to hire you for good, basically. Okay, I'll start maybe with my little introduction. I think we have to repeat here the same as Anna said. You should not give up. Simply, yeah? There are ways of you can apply in all possible and impossible places. You can also go to do something else for a while. There are many people who went out of science, maybe even to banks. Albert Einstein went to a patent office, and then you make it back to science if you want. So I think this, if you love it, don't give up, and it will come. Is that the right thing to do, or not? Or what are your experiences?
Well, you can go different directions. That's always good. When coming back from my postdoc in Japan, I made a stop in US and in Canada. In US, I went to Princeton, and there was at the department, there were 2 Nobel Prize winners. And I was asking the head of the department if all students wanted to join those 2 Nobel Prize winners. And he said, no, not at all. This is not the way how it works. Most of the students at Princeton, you only get the best, the brightest students. They are interested in finding a brilliant idea, making that brilliant idea into a startup, make the startup grow and getting it into something which people really want and become rich and then spend the rest of their life having fun. So that's also a very much valid way of how you plan your life. You want to become rich by having a brilliant idea. That's a good thing. Yeah?
Yes, and I think that studying physics or chemistry or natural science is basically one of the relatively frequent ways how you become a billionaire.
Maybe
not that it happens that frequently.
Maybe you become a billionaire without knowing that you are going to become a billionaire. That's well how the life goes, and maybe you will become a scientist, Nobel Prize winner, or just, let's say, a leader of an institute. You don't have to be a Nobel Prize winner. What I would like to advise you is that there is never, let's say, a time when it's late for something. Because, as you are going to grow up, you will find some obstacles that you will have to overcome, and you'll find some examples around you that, people or friends or your colleagues that are better in something that you are, and don't let that push you back, because you will eventually find the thing that you are good in. And, if it leads you to being a scientist, that's great. But if it leads you to being an artist, for example, I had friends that studied mathematics, but she became eventually a sculptor. Or so where you start, it does not eventually define where you end. And if you focus too much on the present and your surroundings, you are missing out the part that it's most fun.
It's a few years when there was an article in Nature, and they're saying that doing academia and science especially, it's like joining a drug cartel. The death rate is roughly the same. What I mean with that, when you are students, then it's the same as you are working on the street, distributing, whatever. And then the probability that you will become a local boss / PhD is roughly the same as becoming a boss of a district, street, whatever. And then if you want to become a boss of a country, meaning a professor, then you are literally waiting until somebody dies. But there is a way around it. Grow your own branch, grow your own product. There is no way, nobody needed to be killed on the way to grow because there is free space above you.
If I may add, that's basically how the science spreads because, well, as we are studying, then the new ideas are coming and new topics are being discovered, and well, the amount of people is still rising. So, well, there should be enough money to pay more scientists because, well, the population is growing.
So I'm not so pessimistic to think that we have to wait until somebody dies to become a professor, but definitely the scientific environment is very competitive nowadays. But there are different systems, like for example here in Czech Republic we have the professorship as an academic title, but in Western countries it is typically a position. So basically you apply to a competition for a professor position at the university, and then it just depends on your skills, on your previous career. So basically the advice to get the faculty position is just to work hard during the PhD and the postdoc, and I think that the chances still are available.
Okay, thank you. I think we've spent most of our time sounding like old people who pontificate, you know, to the young what they should do with their life and so on. So maybe we stop this, although it might give you possibly once you forget about this, then something wakes you at night and you realize that you remembered something from this discussion of old people. Let's get back a little bit to physics. We've been talking partially also about what we do, which is something like talking about where physics is now. And we talked about sci-fi, which I think is very important in scientists, among scientists, because we draw lots of inspiration from that. But can we now try to think about future of science? Where, I mean, you can choose whether you want to talk about your field or science in general, where science is going. And let's make it not, let's say, only where science is going as a subject, but also where science is going as an enterprise, basically, as something that people do. Some thoughts on that? Who wants to start?
So for me, nowadays, or the last maybe 10, 20 years, there are some aspects of science which are not very nice and which might even like become, or for you, as a or let's say younger colleagues of us may sound or look relatively weird. So nowadays, sometimes in science, the advertisement of the things which are being done is much stronger than the factual or let's say the outcome of the particular experiment. So for example, you all heard whatever 1 month ago about breakthrough in the nuclear fusion, which from one point of view can look like a real breakthrough, but from the other point of view it might look like a good advertisement for funding agencies to support the particular experiment for a longer time. And I would say that this aspect of science we all should try to somehow suppress. It is very hard because, of course, we already discussed here the money which goes to science must be distributed somehow, and unfortunately nobody came with the best possible system up to now. So we have to work with what we have. But for me personally, this aspect of science I would like to avoid in the future.
Like, from my point of view, it's really important to jump between the fields, that you get inspiration. Like, I was in a lab and they have a procedure which resulted in nanoparticles after 5 months. And I was like looking on it and I was like, why you don't use this machine which is used in biology? We just can just twist it a bit. And then the production they have, instead of half a year for waiting one sample, they could produce them within 1 batch per 2 weeks. Yeah. So, and that was just because from your perspective, you look on stuff differently. Yeah. So it's a win-win situation for both. Yeah. And the field can be biology, chemistry, biology, history. All fields are having somewhere connections between them, and the more richest and fastest going science is on the borderline, in like from my point of view. So don't be afraid to jump from field to field. It's not lost time. It's just the worst thing can happen. You get new friends and you get new experiences. Yeah. So jump between the fields and find your niche.
So the future of science, if I may freely translate that, is in interdisciplinarity.
You can say so.
Yeah. All right.
Well, there's future of science and there is a future of humanity as a whole, because as you are, well, recently aware, we are going to eventually be replaced by artificial intelligence or some computerized and mechanized approaches. And it leaves that in the future there will be only 3 types of people. Caretakers, artists and scientists, because these are the subjects that everyone would like to, each of us can really enjoy. And the future of particular subjects only depends on, what we as a humanity would actually like to do. We will soon have, the means of doing anything very fast and very large scales, if everything goes well. And, for example, the interdisciplinarity could be one of the subjects for you to tackle, because you won't find enjoyment maybe in one particular case. And as for example, for my field, fate is quite clear and grim, because once we get it done, we'll probably get defunded. So we will work hard to get it as fast as possible, but it's also our doom, because for everything, when it becomes widespread, research is not cool enough to draw new people. But if you are giving your heart into the subject, it doesn't matter.
My answer is slightly different, because I don't care too much about science. I am doing research because of the energy problem, and we want to find the solution which would work, which I believe photovoltaics is. I thought that I will not have to say this, because Aleš would say it already that, because they are having the same motivation as us. It's finding the future source of energy, and I don't care too much about publications. I care about getting it done. So, yeah.
Okay. All right, good. We were supposed to talk, all this event was supposed to take some 90 minutes. So I think we are slowly approaching that. I would give one last round with a funny question. What do scientists do in their free time? So I play rugby. What about you?
I spent a lot of time doing the singing in choirs.
Okay.
That was a good way how to find my wife, and since then I don't sing in the choirs.
So actually, I when I have some free time, because I have 3 kids, so then I play soccer a little bit. But yeah, I'm becoming a little old for it, so, so physics will probably remain the only hobby, and the kids, of course. So that's
Right.
So I have 10-month-old baby, so for me it's the sleep.
Well-
When I can have some. But in meantime, I do a lot of volunteering because like the Westmere, I volunteer in there because I think it's important not only speak with you, which you will probably become future scientist, but also to general public to interpret what we are doing, why we are doing, and what's new in a language which they can understand, because they should enjoy it a bit as well, because it's great fun.
Yes, I'm a bit of a stereotypical product of our faculty. So I I enjoy all the nerdy things that can be attributed to the scientists. So basically, if you watch Big Bang Theory in your free time, then it's basically me. But I don't think that there is that is necessary, because scientists are basically people. So
Really?
but yes, biologically at least. And free time activities range from sports to reading books. So like for me it's puzzle hunts that I spend on more time with. But I don't suppose that you understand what it is, because it's a very Czech thing to do. And so
Okay, thank you. So that is not all, because you can, of course, ask questions if you think that there is something that you want to know from, well, let's use that word, real scientists or partially accomplished scientists. So maybe we can use the microphone if there are any questions.
Don't be afraid, we don't bite yet.
You have mentioned the recent accomplishment in the thermonuclear fusion. It was done with lasers, and I would like to ask if the laser technology used, especially in the USA, has any future next to the tokamaks, and what kind?
okay, it's probably on me. I think that laser fusion is much harder to accomplish than tokamaks, but no one should actually do harsh decisions on the complexity of the research, because even if you don't let's say find the solution, let's say faster than the other topics. For example, in nuclear fusion, a lot of startup companies recently appeared, and maybe they got it right, and they will be faster than us. But as was said before, the main goal is to provide this energy source, and it does not really matter whether it's laser fusion or our magnetic confinement. So they have many different problems than we do. And since I'm not a laser physicist, I know them only from hearsay. And it seems that it's much more difficult. But it's not the only way to do it like we do.
Okay.
Can I add a little comment on that? That's the way how we discussed it just today. That announcement was of the energy gain. So they got about, not even twice, but energy gain, which was about 1 megajoule by this tritium pellet exploding. Now, to make this into a real power plant, you need to have a power which is on the gigawatt scale, a very common nuclear power plant. So you would need to have that pellet exploding 1,000 times per second. The current state of things is that in National Ignition Facility, they are exploding 15 pellets per year. And that is the current state of the art, and challenging enough. So there is a large gap between the aspirations and the reality. But you can also tell that story in an optimistic way. There is plenty of space what you can do.
For example, it opened a brand new topic of burning plasma with high energy gain, because it was not they were not able to study it before these kind of experiments, and these studies will probably be beneficial even for us. Although the plasma is kind of different, but we need to study it before we actually start producing power plants.
But if we look on the time scale, like discovery of lasers, it took 10 years until it was used in physics, and now everybody of you have a laser in your pocket. So eventually we'll go there. It might take 1 year or 20 or 30 or eternity. Who knows?
As always, it will take 40 years from now. It used to be like that 40 years ago. Okay. All right. Some more questions?
I would like to ask how important it is to know and to be able to use programming languages like Python and etc.
As an experimental physicist, I can tell you that it will make your life much easier if you know it. So basically in the lab, let's say maybe 80% of work when preparing the experiment is really programming different devices to act together. And definitely I would recommend to take classes in this field. Like Python nowadays is very often used. And I think everything can be, let's say, programmed with Python and controlled. So if you are considering this as a complement to your physical studies, then definitely I can recommend it.
I think that it's absolutely necessary to know how to code or to work with data analysis tools. Maybe it will get more easier with, for example, the artificial intelligence applied. But as if you want to build something, you have to know the building blocks.
Don't worry if you hate programming. Just pair with somebody who loves programming, and at least learn to think as a programmer, because you need to translate to them what you want they create for you. Because if you are dyslexic, programming is lost game for you. The spell checker you will spend lifetime to find the mistakes. So yes, if you can do it, go for it. If you don't, find a way, find somebody who will do it for you.
I can confirm, because you are experimentalist, I can confirm that in the theory side of our science, it's basically the same. It's an absolute must, not an absolute one, but there are only very few people who can do their science only with pen and paper. I'm trying as much as I can do only pen and paper, but sometimes I get to this programming frenzy and spend a week basically just programming, because it's fun. It's fun and it's useful. It's almost necessary in all theoretical fields. Okay. We can hear you, that's fine. Shout, please.
So, I wanted to ask you, are you rejecting that decision that you made in the past? And what would you like to say to yourself, but in the past? Why? When you were 15, 18, and you were frightened to choose university, your future job, or maybe a little scary, confused?
Who was scared?
So To be honest, I was not scared at that age. I was probably thinking about different stuff. But actually now I cannot say I would regret the decision any single day, because actually in the academy you have really a lot of freedom. So basically the topics which you want to study are mostly up to you. And when you do things which you love, or they are your hobby in the same time, then I don't think there is any reason to regret this decision.
I think you make the decision not once, of course. There are many stages at which you have to make a decision. I have had 2 occasions, basically after master's and after PhD, where I was inclined to decide against science. And I didn't do that. I stick to science, and I never regretted that. And about that situation of young age, I think it's perfect. It's perfect to be naive. It's the greatest of situations. You know, if you live in an environment that doesn't kill you behind every corner. But I think we have sometimes now the luxury of, let's say, the decisions not being the decisions of life and death. You know, if you decide to do physics and you are destined for chemistry, nothing so terrible will happen. But you have the advantage of not knowing everything. I think we've touched some of the aspects of science that are relatively hard to swallow for us who practice it, but you probably should ignore these things, because you at least at this stage, you are allowed to be naive about your expectations from science. And that's the only way how you can, it's like when you are looking for a partner for your whole life. I mean, at the beginning, you are, of course, naive because you think that's the best person you found, the best person in the world. Obviously not, but if you spend 20 years with them, they are already the best. All right, so that's basically the approach that you probably should or could take, or at least consider.
I would like to add that I also had several times I was considering giving it up, and I'm glad that I didn't. But all the things that I actually regret are the ones that when I actually did not ask a question that I could have asked. Because the science is not about your own work, but to putting the work into the context and gaining experience from anyone, basically. And there are some times that when I should have asked and I didn't, and these are the points that I regret.
So first year at our university, I was like thinking, what did I have done? I was accepted also on Faculty of Economics, and I was like, you're stupid to be on MathVis because it's so difficult, like how you will survive. It would be much more easier to be on Faculty of Economics, but I would not have such a fun. Yeah. So always you question yourself, but the ultimate question is, even though if you don't like the current state, is the result something you love to have? And if the answer is yes, then you try to survive, and if you survive, you get the gift on the end, which is a really nice career and to do what you love. So yes, there are points of regrets. You can do always something better. But each step ask yourself, even though it was a mistake, I learned something and I'm a clever person than I was before. I know how to avoid these problems, and it lets you grow. If you do not do mistakes, you do not learn anything. So even bad stuff makes you better.
Okay, do we have some more questions?
Yeah. Well, I have not very typical question for scientists, but it really interests me. As you mentioned, the scientists have also a free time. Do you play video games, or do you have any experience with video games?
Please.
So actually, I have experience, but from much younger age. And at a certain point, I found that it really just eats your time, and you should stop. But I don't say obviously. But I mean, probably every one of you have some friends who are like spending more time than is healthy with these type of things, and I think you can probably find some balance even in science. But actually, I would say that I'm kind of looking forward to spend the free time in a little bit better way than like playing video games nowadays.
Like, I wasn't a video game person, but the only reason was that on the end, I didn't have anything I could touch and I could keep. So I get in real-time games, so outside with friends, or creative, that I went for pottery course and I was doing pottery because I was like, okay, how it works. So something creative, gaming in real time is better for me because you can keep the results or give them to somebody.
I used to play some video games on high school, but eventually I stopped because I didn't find it as funny as, for example, playing board games with friends, because, well, you can play a board game, drink some beer, and, well, have fun. So it does not isolate you. Well, the experience when there are some friends is much more richer. But eventually you can get this experience when playing online games as well now. And I see some colleagues that are doing it. So, well, it's up to you how you spend your time. It's not very, I think that there is no good way. It's just what suits you.
There are also some games that actually quite promote some scientific knowledge. I started to play Kerbal Space Program with my son. Wow, amazing! So I would not say that video games per se are something bad, but I think it's a question of time. At some point, you really need to stick to real hard work. And then there is not much time to play video games, even the good ones.
But I'm hoping that in half a year or a year, when the little one gets bigger, we will buy a robot and we'll start to program it. And I'm looking for these games forward with the little one.
Actually, I bought a Witcher game 2 years ago, and I didn't find the time to play it, because even if when I wanted to, well, I was basically too tired to try.
Go play it, it's great. Right. Thank you for the advice. All right, is there any other question? Yes.
I'd like to ask how much space is there for pure computer scientists in science, but I guess mainly physics?
Maybe I'm actually the closest to that through my sort of theoretical interests. I would say, yes, there is a lot of place and space for that. Actually, you can do computer science, so you can do computer science sort of itself. But I would right now love to have somebody in my research group that could do the programming on a professional level, or let's say optimizing my code, or figuring new algorithms, how I can deal with data, and so on. This would be amazing. The problem is that, for instance, one of the problems is typically again money, because if you do something like that, know it very very well, you can be easily hired by a private company for 3 times the amount of money that I can give you from my grants. So yes, if you would be that computer scientist who would give up the big money and go to help people in fundamental research, that would be fantastic.
Yeah, I can add. I can confirm that it's nowadays it's very useful to have someone with a computer science background in your team, not even for the basic tasks, but for let's say huge accomplishments. As a nuclear fusion, we have a dedicated facility in Spain that actually helps physicists to optimize the codes and run it on large computers. Now we are a part of some European grant that is actually developing code for exascale computers. That means well, computers that are even bigger than the biggest one that are available now. And well, physicists cannot do that. It has to be done by computer scientists because, well, we are trained to do physics and then do some data analysis or write some models. But to be a good physicist does not necessarily mean that you are a good programmer or a good computer scientist. And furthermore, I wanted to add something that I forgot now, just so maybe.
Like, we are quite small country with relatively restricted resources. So in here, you need to be a bit of, not computer scientist, but also something to be added. But around the globe, there is plenty of space and plenty of money that allows you to be just pure computer scientist. Yeah, so you just need to go to the country which has that resources. But eventually we will become that country as well, because the trend is going there. So there is a space in the globe for you, definitely.
I remembered. I have friends in computer science and in, let's say, in startups that are making a huge amount of money. But, well, they are starting to sense that it's just making money. And several of them are actually moving to, let's say, lesser earning positions that bring more sense to their skills and their application. So it's also a possible career choice to earn a lot of money and then be a scientist.
I understood that question differently. So maybe I would also add a different answer. I think there is a huge space for doing something completely different in computer science. If we see the quantum computing taking off, then the computers, as we understand them now, will be something which is on a different level. The quantum computing may become so powerful that what we think about computers now will be just peanuts, completely obsolete. But we have no idea how to really ask questions from the quantum computers. There are very few quite elementary tasks for them, and I think their potential is way, way higher. So we will see, maybe in just a few years there may be a revolution in that, or maybe it never comes, who knows? Yes, there is plenty of space there.
Okay, so is there any question that somebody would not sleep if it was not asked? Okay.
Okay, so I'd like to ask about politics, maybe a bit of economy about energy, like the old school nuclear reactors, not the fusion ones. They are a bit on a decline because there were some accidents, disasters. Yeah, it's really declining. Also, it's like really clean energy. The only waste is like the water and yeah, they changed the roads, they are radioactive, etc., but they are on a big decline. Do they have any future? Like,
let me answer that as somebody from a different energy direction. Photovoltaics is actually not a competition for the nuclear energy. They are quite natural partners. I do not see space for the nuclear electricity to become a dominant direction. Really, there is no space for that. But they have a very fundamental role for the security of our energy systems, because you can control them, you have a storage of energy there for decades, and they will be the backbone of the future energy grid. On the other hand, the supply of electricity at the moment is on the level of about 15% globally, and it will not go much higher. That's my expectations. There may be a technical development which will make it different, and those are the reactors of the 3rd and 4th generation, plus the mini reactors, modular mini reactors, and there is quite intense development in that direction. So it's by far the field which is maybe in slight decline now, but that's only, we still wait for some breakthroughs and they are coming. I'm almost sure.
I would like to comment on this. We have waste from these plants for like 30, 40 years, and we just store them somewhere, and like we are saying this is waste. But recently they took the waste, which is 30 years old, and they recycle it, and they get new ingots out of it, which you can reuse. So the waste is becoming a new fuel for the new plants. But if you look on the energy, like 30, like from 50, like, oh, Norwegia is fine, that's like 0, but there are countries which you have 30 or 40% when you burn fossils or waste, which is the main problem. But saying that, it's like 3 years that in Sweden they discovered a really nice plant, like burning plant, that it goes on a really high temperature. So yes, it produces a bit CO2 of it, but it's clean source, clean burning. Yeah? And they feed it by waste. And out of 1 ton of waste, they have about half a kilo of something dangerous which they need to store somewhere, like kilo or grams. So the Sweden started even import the waste from the other countries because they have this clean burning. Yeah, so we develop it in all ways, like solar plants, they are trying to make it better, but in night you don't have a light, of course, yeah? So then you have these plants which are burning stuff to get more efficient, that nothing except CO2 goes outside. And then you have these nuclear plants which are using the wastage already, which is like 30 years old, which we said 30 years ago, we said, no, for 1,000 years you cannot touch it. And then you have this another source, which hopefully will be also a future. So we try to develop it in all the branches, all the ways, and we hope that one of them will be successful, that we will have more cleaner source of energy on this globe.
Okay, so it looks like science. Can you hear me? Well, okay, I'll shout. Okay, science may not be the answer for everything, but at least it answers enough so that we can live with it. So unless there are some more questions and really pressing ones, I would close the session. I think we're supposed to be 90 minutes. Yeah. So we are already way over, but hopefully that's because we were talking about interesting stuff. So let me thank all the panelists. Again, let me thank you as a wonderful audience that was brave enough to ask questions. And I understood that your competition is taking place tomorrow, so I wish you all the best. Let the best win, and let the not best not to be that bad. And well, hopefully see you sometimes in future at conferences, because that's what scientists do also in their free time, I would say. Yeah. And okay, enjoy Prague, enjoy this place, and be nice to each other.